Are we going? We are live. Awesome. Okay, so today we want to talk about logarithms. Logarithms. Sounds hard, but they're really actually not. Trust me, they're not. So logarithms really are exponents. And what they do more than anything is they help us solve for unknown exponents. And I'm going to show you an example. Before I even do any of the rules, I'm just going to show you an example, okay? So my example is this. If I have 10 to the x power equals 753. I just made that number up, okay? Okay, you guys okay with that? So, the answer's got to be bigger than 2. Now think about this. 10 squared is 100, but smaller than 3 because 10 to the third is 1,000, right? So I'm guessing the answer is about 2.8, maybe 2.7. Now I could guess and check, guess and check, guess and check. I don't want to do that. That's just like crazy. There's got to be a better way, right? I mean, it's got to be. So 10 to the 2.7. Let's see how close I am. No, got to go bigger, right? So 10 to the maybe 2.8, right? You see, I'm getting closer, but that's a crazy way. Guess and check. So what we're going to do is change this to a logarithm. Log base 10 of 753 equals x. So logarithms, see what logarithms can do? It's going to solve for this x value. So on my calculator, I have a log button. You guys see the log button? It's right there. So when I push that button and I go log, guys, okay, if I go log. Now one of the things you don't see is this 10, okay? So this 10 is called common log because we live in base 10. Why do we live in base 10? Because we count, right? 1, 2, 3, 4, 5, 6, 7, 10. And again, and that's because we have 10 digits, right? So we live base 10. So if you don't see the number, it's invisible, and it's always 10. So that's called common log. So I go log of 753. It's about 2.87, blah, 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 blah. So that means that 10 to that power, right? 10 to the 2.73, blah, 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 should equal 753, right? Should. What do you know? Cool. So logarithms are probably pretty handy, aren't they? Right? Pretty darn handy because they allow you to solve for the exponent. Okay, now, what we want to do is take logarithms a little bit further. So if we take, and this is exact what I have up here. I have my base, which is my 10, to some exponent equals the answer. Okay, here's my base 10, to some exponent equals some answer. You can then rewrite that in what we call log form, which is what I did. I went log of the base, it's base 10, of the answer equals the exponent. So that's exactly what I did here. I took this exponential, 10 to the x power, and rewrote it as a log. I will. So if I go log, and then the base is invisible, okay? You don't see the 10 because common log. Now there's ways to get other bases, but if you don't see a number, it's always base 10, okay? You guys got that? If you don't see a base number here, it's always base 10. And then we're going to go 753. And that's the exponent. That's the exponent. 10 to that power will equal 753. Pretty handy. Okay. So now, and of course I wrote it out in words, but I like the abbreviations easier if you just use the abbreviation. But I wrote words, okay? So, now there's a couple of things we want to look at. One has to do this E, okay? So if you deal with E is a unique base also because we've looked at E, and E is considered a special number. We looked at that the other day, and it's called the natural number. E is called the natural number. And E is the natural number because we find it as continuous growth or continuous decay, which is something we use in nature. You're going to see it in all of your upper science classes, okay? So if you see that, then we're going to use a different button. So instead of log base E of some answer, if you look at your calculator, you'll find this button too, ln. Well, ln means natural log, so when you push that button, okay, clear. If I push this button, ln, you can see the ln right here. If I push ln, again, invisible base, but the base is E, okay? So there's two very special bases, One is common log base 10, and there's natural log base E. So I could say, for instance, if I want to do E to the, let's go natural log of 2, okay? So I get an answer. What is this? This is E to some value of x equals 2, and we found out what the value was, okay? Now, we have two special bases. We have base 10, which we know is common log, and we have base E, which is natural log. And any other base, you have to say the base. This is base 3, okay? So we're going to change this from log form to exponential form, okay? It's actually pretty easy. Watch. 3 is my base. So I'm going to rewrite this as 3 to the x equals 81. That's all I did. 3, that's my base, to the x power equals 81. And of course the answer should be 2, right? This answer is 2, because 3 squared is, oh no, that's not true. Wrong number. 81. It's 4. There you go. My bad. Okay, B. So if you look at B, what's the invisible base? We just talked about. I don't see a number here. What's the invisible base with natural log? What's the invisible base? There's an invisible base number. There's a number E. Thank you. It is E. E is my invisible number. I don't need to write it, but I will. So I'm going to take E, because that's my base, to the x equals 2. So I rewrote it from log form into exponential form, okay? How am I doing? Okay. Change the following to a logarithm form, okay? So let's do the opposite. So I'm going to go log. It says log form, so I'm going to have to go and rewrite as log, L-O-G. 10 is my base. 10 is my base. So log base 10 of my answer equals x. So log base 10 of 1,000 equals x, okay? And then you can do that on your calculator. It's log base 10. The answer is got to be 3. We know that, but I can just go log 1,000. Let me turn it on, clear. Log 1,000. The answer has to be 3. And it is, okay? Because we know that 10 to the third power is 1,000, okay? Okay, letter B. What's our invisible base? Again, I don't see a base, but what's the invisible base? E. Okay, good. Okay. Change the following to a logarithm form. It already is in logarithm form. I need to redo this one. But it could be log base E of x equals 2, or better yet, e to the 2 is equal to x. I like that better, okay? All right. Am I doing okay? So find the value. Wow, what the heck? Log base 2 of 32. How do I do that? Well, you can do this because you're smart. 2 to the x. There's my base. My base is 2. So I'm going to go 2 to the x power equals 32. Okay, now let's be smart. 2 to what power equals 32? 2 to what power equals 32? Hello, 2 to what power? Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, and 2 times 2 is 32. So how many 2's did I say? How many 2's did I say? 5. Right? Now, let's just say you happen to have a fancy, do you have a fancy calculator? You have a fancy calculator. Okay, now watch and type this in carefully. So go to math, hit your math button. Hit your math button. Scroll down, scroll down, scroll down, scroll down. Oh, log base. What's that going to do for me? I don't know. Let's see. Log base of 2 of 32. Oh, you mean these calculators will do this problem for me? Heck yeah. So let's see what we get. I know the answer is 5, right? I know the answer is 5. And what do I get? 5. Sweet. Okay. All right. Okay, let's do B. What's my invisible base? What's my invisible base? I don't see a base. What's my invisible base?
10.
10. Thanks, Dallin. It is 10. So if I set this equal to x, I can solve. So I'll go 10 to the x power, right? 10 to the x power equals 100. Okay, so 10 what? What's x have to be? Come on. 10 to what power equals 100? Oh, you guys are, thank you, Spencer. Too, thank you. I know, it's Monday morning. You guys agree?
How did you know that the invisible number was 10?
Okay, great. So there's two invisible bases. Two invisible bases. One is if there's no number, if there's no base, it's always 10. Base 10, because we live in base 10 world. The other invisible one is this one, ln. If you see ln, the base is e, okay? Those are the only two invisible ones. Otherwise, the base is going to be given to you, okay? So if it's invisible base log, it's 10. If it's natural log invisible base, it's base e, okay? Oh, and you know what? I think my calculator could do this problem, right? I love my calculator. So if I go log of 100, I think it'll do it for me, right? Boom. 2, what do you know? Shoot, technology is always good, okay? All right, ln of e. Well, okay, you ready? Chloe, I'll pick on Chloe. What's the invisible base? It's e, isn't it? So one invisible base is 10, the other invisible base is e. So let's set this equal to x, and I'll go e to the x power. E to the x power equals e. Well, what's the answer have to be? X has to be 1, okay? X has to be 1. Thank you, Spencer. Somebody's awake. But my calculator should be able to do this, right? I should be able to actually do this if I go natural log, ln. You guys see my natural log button's here. There's my natural log. So I'm going to push that button. I'm going to go ln. And then I've got an e button over here by my division. You guys see the e button by my division, but it's in blue. So I go second e. And see how smart you are, Spencer? There it is. 1. So the calculator can do these. Isn't that sweet? Okay, turn the page. Okay. All right, let's see if we can be smart. So I'm going to go base 5. 5 to the x. 5 to the x equals 1 over 25. Okay, so what's x going to equal? Anybody know? Well, let me go a little step further. You okay with that? 25, right? Pi squared. What if I bring this up? What would happen if I bring that up? What would happen to my exponent? So I'd have 5 to the x equals 5 to the negative 2. What's the answer?
-2.
Oh, you guys are so smart. Negative 2 is the answer. Awesome. Okay. E. Well, let's set it equal to x. I'm going to go 5. That's my base. 5. My base. 5 to the x equals the 5th root of 5. I can write this as an exponent. I'm going to write this to the 5 to the 1/5 power. See, that's the same thing as 5 to the 1/5 power. And so what's this thing have to equal? 1/5, right? Is this too early in the morning for you guys to think this hard?
Yeah.
Okay. All right, what's my invisible base? What's my invisible base? 10. Invisible base is 10. So I'm going to go 10, that's my base, to the x power equals 0.001. I think that's like 10 to the negative 1, 2, 3. If I went from scientific notation to exponential function. So what's this thing have to equal? What's the value? Negative 3, right? Now in this one, you can say, hey, Mr. Davies, it's like my calculator can do f, right? You guys agree? Why did I have to do it the hard way? Because Mr. Davies wants you to think. I like it when you use your brains. But you could go 0.001. Guess what you're going to get as an answer? So the calculator can do it for you, right? Okay. G. All right, I'm going to go 3 to the x equals 1. All right. What's x have to be? Good. Anything to the 0 power is always 1. Spencer's awake for Monday morning. Nice job, Spencer. At least somebody's awake, huh?
Yeah.
You agree that it's got to be 0, anything to 0 power, so the value x has got to be 0. Okay, I like that. Okay. All right. I'm going to go 4. That's my base. 4 to the x. Okay, 4. You guys starting to get the hang of this? 4 to the x is equal to 4 to the third. Well, that's easy once you do that. Oh, 3. Okay, guys agree? 3. Okay. So here's a rule. If these two are the same, these two are the same, the base and the answer the same, they kind of cancel each other out. Okay. Log of 0. Right. Okay, what's the invisible base? 10. You guys agree? Invisible base is 10. I'm going to go 10 to the power of x equals 0. Impossible. Impossible. No solution. In fact, I could probably try it on my calculator because, like, I could try it. Let's try log of 0. Let's see what it says. No, domain error. Now, why is that? Well, let's graph it. Log of -2. I think this one's impossible too. 2 to the x equals -2. That one's impossible too. In fact, if I try it on my calculator, clear, I go log of -2. That's an error. So why are these two no solutions? Well, let's graph it. Let's take a look at it, okay? No solution, okay?
Wait. But when you typed it into your calculator just then, you did the base too.
Good. I was wondering if it won't make a difference, but I'm glad. No, but you're right, Down. Let's take it, look at it. Log base 2. I was wondering if anybody pick up on that. Still no solution, right?
Okay.
Yeah, I just didn't want it. Yeah, I was getting lazy, wasn't I?
I was just wondering.
So here's the deal. Think about this. If you have a number, any number, okay, any number to the power, okay, what it's like you can put in numbers, like I can put, let's just take 2. 2 is the easiest. 2 to the x power. So 2 to the 1, okay, is watching. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8, right? 2 to the 4. 2 times 2 times 3 is, okay, but if I go 2 to the -1, what do I get? I get 1/2. You okay with that? 2 to the -2, I get 1/4. So this is like stepping towards the wall, okay? I'm going to go halfway to the wall, halfway to the wall, halfway to the wall. This keeps getting smaller and smaller and smaller, doesn't it? Smaller and smaller and smaller, half, and you go to 1/8, you go to 1/16. But will you ever get to 0? Can you ever make this 0? Because you're going to go half. So we find out, not only can you not get to 0, but you can't get negatives either. So what we find out is that the domain of any logarithm, any base, is always going to be, the domain is always going to be x has to be greater than 0, okay? So logarithms can't be negative. So if I look at the graph, and I'm almost done with today's lesson, if I graph, first we'll graph this one first, and I'm going to use points. If I plug in 0, I get 1, so we'll point it 0, 1. If I plug in 1, I get 2. If I plug in 2, I'll get 2 times 2 to the 2 power is 4. 2, 3, 4. And I'll do one more. If I plug in 3, I'll get 2 to the 3rd power is 8. 1, 2, 3, 4, 5, 6, 7, 8, right? And over here we were actually doing it. If I plug in -1, if If I plug in -1, I'll get a 1/2. And 1/4. So my graph, my exponential, looks like this. The logarithm is the inverse of it, okay? The logarithm is its inverse. Well, the way we did inverses before is we just switched the x and y values. Remember doing inverse? We just switched the x and y's. So if I switch my x and y values, I'd have a point at 1, 0. Right? I'm just doing the inverse. I'm taking the opposite of these. So these points I'm going to inverse. 2, 1. I'd have a point at 2, 1. God bless you. I'd inverse this, and I'd have a point at 4, 2. 1, 2, 3, 4. 4, 2. 4, 2. If I inverse this 3, 8, I'd have a point at 8, 3. Let's go 1, 2, 3, 4, 5, 6, 7, 8. 3 is up there. If we inverse this one, we'd have a point at 1/2, -1. Let's see, 1/2, -1 is here. So my log graph looks like this. Okay, two things I'm done. My exponential has a horizontal asymptote here. What a horizontal asymptote is a boundary line. Okay, this is my horizontal asymptote. Okay, at y equals 0. It's like a boundary line, right? It'll never reach 0. You guys agree? We've all talked about that. Okay, but then we'll have a vertical asymptote for our logarithms because the graph itself will never reach 0. Okay, so that's what I have. Not too bad. Logarithms. Okay, so you guys we are going to drop the egg. So it's up to you whether you need to work on your egg drop. Come on, stop recording. Oh, this thing's so annoying. Stop. Stop recording. Stop recording. Last time I yanked it out while I was still going, it destroyed the